Hello, welcome to my class. In this class, we are going to discuss question number 3 from exercise 8.1 from the chapter Quadrilaterals. And this class is for class 10. Okay. The question is, show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. And before starting to solve this question, let me tell you one thing. If you have not subscribed to my channel, please subscribe and do like the video if you like my class and share it with your friends. Do not forget to click the bell icon to get notifications also. Okay. And if you have any doubts, you can ask me as comments. If you have any suggestions, that is, if you can't understand my class, you can comment that also. Okay. So let us start solving now. The question is, if the diagonals of a quadrilateral bisect each other at right angles, then we have to show that it is a rhombus. So we have drawn this quadrilateral A, B, C, D. Okay. And given that these the bisectors bisect each other, that is, this is equal to this and this is equal to this at right angles. Okay. All these angles are equal to 90 degree. So we have to prove that this is a rhombus, that is all these sides are equal. We have to prove. Understood? So we have named this center as O and take triangle AOB and triangle AOB and COB. Triangle COB, that is, we are taking these two triangles. Okay, so take triangle AOB and triangle COB. Now, we know that this OA is equal to OC because it is given that the diagonals bisect each other. So, we can write OA is equal to OC. And this OB is the common side of these two triangles. So, OB is equal to OB, common. So, we can write here that diagonals bisect each other. And this is the common side. We can write common side. And we know that this angle AOB is equal to angle COB. Angle AOB is equal to angle COB is equal to 90 degree because they bisect each other at right angles. We can write bisect each other at right angles. Diagonals bisect each other at right angles. Okay. So here the reason is diagonals bisect each other at right angles. So from this we can say that this triangle AOB is congruent to triangle COB. Understood? So this AB is equal to BC because they are the corresponding sides. AB is equal to BC. So we got two sides which are equal. Now this AB is equal to BC. Okay. Now we have to prove that all these sides are equal. Now take these triangles AOB and AOD. So we are taking triangle AOB and triangle AOD. That is these two triangles we are taking. Okay. And here also OA. This is the common side. OA is equal to OA, common side. And this angle AOD is equal to angle AOB because diagonals bisect each other at right angles. You can write 90 degree also. So, we have got one side and one angle. Now, this OD is equal to OB because diagonals bisect each other. So, this is equal to this. So, OD is equal to OB. Diagonals bisect each other. Okay. So, from this we can say that triangle AOB is congruent to triangle AOD. We can write triangle AOB is congruent to triangle AOD. By which rule? Two sides are equal and one angle in between the sides equal. So, SAS congruence rule. And here by which rule? Here also SAS congruence rule. Okay, so we have got these two triangles as equal, which means AB is equal to AD because they are the corresponding sides of congruent triangles by CPCT. Here also by CPCT, that is corresponding parts of congruent triangles rule. Now take these two triangles. Okay, we can take any triangles, but now we are going to take these two triangles, triangle AOD and triangle DOC, or a triangle D. We can take like this, DAO and DCO. So we are taking triangle DAO and triangle DCO. Okay, and here also OD is equal to OD and this OA is equal to OC and angle DOA is equal to angle DOC is equal to 90 degree. So this triangle DAO is congruent to triangle DCO, which means AD is equal to DC. Okay, so AD, we got AD is equal to DC because they are the corresponding sides. Now we have AB equal to AD, that is AB is equal to AD. This is 1, the first part that we have solved. This is second, and from 1 we have got that AB is equal to BC. Okay, and from 2 we have got AB is equal to AD, and from 3 we have got AD is equal to DC. Okay, so AB is equal to BC and AB is equal to AD, which means BC and AD are also equal. So AB is equal to BC is equal to AD, and this AD is equal to DC also. So we can say that all these sides are equal, which means this is a rhombus. In a rhombus, all the sides are equal. Okay, so we have proved that this is a rhombus. Okay, understood?